In this problem, we have a concentration of a weak acid solution. We have the pH, and we're asked to find the Ka. Well, when we have a weak acid solution, we know it's in equilibrium. So go ahead and write the equilibrium for the acid. Alright, so the K is equal to the concentration of A minus times the concentration of H3O plus over the concentration of HA. So I'm starting with 0.3 molar and none of the products. When I do the change, it's minus X plus X plus X. Remember that water is a pure liquid, therefore it's not included. Alright, so I get 0.3 minus X, X, and X. And normally for a regular problem you would just plug it in and you would already have K and you'd solve for X. However, in this case, we're given the pH. Well, pH is equal to negative log of H plus, which is the same thing as H3O plus. Therefore, we already know what X is. Alright, so if we plug in the pH and solve for the H plus concentration, we get H plus is equal to 6.31 times 10 to the negative 6 molar. So therefore, we have 6.31 times 10 to the negative 6, 6.31 times 10 to the negative 6, and 0.3 minus 6.31 times 10 to the negative 6 is equal to something. I'm just going to plug that in, and plug this in, and plug that in, all to this expression. Alright, so K is equal to 6.31 e to the negative 6 squared, since both of those are the same, over 0.3 minus 6.31 e to the negative 6. And when you punch that in, I get 1.33 times 10 to the negative 10 for the value of K.